Recording going. So yeah, welcome in everybody. Happy Tuesday. Recording is up and running. My apologies for the lack of recording on the YouTube channel on Tuesday. Ran into some technical difficulties. Long story short, it didn't convert to a file that allowed me to upload it to YouTube. So I spent a couple hours trying to figure that out. Much frustration, but eventually just realized it wasn't going to work. So hopefully today's is better. I think I might have remedied that issue. So if you're here, obviously, right now, you're seeing this, it's irrelevant to you, but if you happen to be one of the people tuning in on our YouTube channel later on, welcome. All right, so let's get to business today. When it does that, sorry about that. Let's try this again. Seems to do that at least once every class. Okay, Edpuzzles, we know that some are due this Friday. I see a lot of you have been kind of working them in, continue to do them. Good job. Some new Edpuzzles have been posted this week. Feel free to continue to get those done at your leisure. Those will be due a week from tomorrow, okay? So keep working on those Edpuzzles. I return them to y'all based on correctness, but when I input them into Infinite Campus, it's based on completion and effort, okay? So even if you get a 20% on the Edpuzzle, I'm looking at that as our classwork taking place of our in-person classwork, and that will be graded and entered into your grade book once you complete a majority of them based on completion. All right, so continue to work those through. Next up, remote learning agenda. So use it for class pace. That's this thing. As you can see when it loads, right on, there it is. This week, the 14th, which I checked off already in row 9, and row 10, we're working with less than 5, which is all that idea of using the distributive property at a higher level now to FOIL as we learned the mnemonic device on Tuesday. So if you weren't here on Tuesday, no stress. I think through today's example and examples and problems, we'll be able to get pretty good at that process, because theoretically speaking, a majority of this unit, although it's difficult and it's new from a in-depth learning perspective, a lot of the stuff that we need for this unit, graphing is going to be on what we talked about last unit in transformations. Foiling is just the distributive property. And then eventually when we learn how to solve for those x-intercepts, which we'll call roots, some of you have done that Edpuzzle, which is awesome, we'll see that it's just an application of something that we learned in the first semester called the zero product property. But I digress. I don't want to get too off topic here. What you see in front of you is that remote learning agenda. Please continue to reference that for pace. But also, if you ever have any questions, never ever hesitate to ask me, both in these sessions via email or the remote learning questionnaires. So it looks like my screen has frozen. There we go. Okay, we're back. Right on. So extra Zoom session. This one's super important. This is what was previously called the office hours. I'm opening up Zoom sessions similar to this, extra classes where I can be here face to face to help y'all tomorrow, aka all Fridays from 10 to 11 a.m. Tomorrow's specific Zoom session is going to be covering 2 things. The first part of the session is going to be on the U7 assessment, the Unit 7 assessment, which a lot of y'all have done a good job completing. I saw some really good scores on there, so fantastic work. We're going to go over specific problems, like the last problem on that assessment there, and we're going to use that as an opportunity to really kind of wrap up that idea of transformations, shifts, and reflections and stretches. Okay, so I would love for all of y'all to be there tomorrow for that. We'll be covering that, and then we'll be going over any and all homework questions and class questions that you have on this current unit, foiling. So hopefully I'll see you then. That'll be every single week, okay? Optional AMA, which is the Ask Me Anything. It's effectively a situation where you could ask me math or productive and appropriate personal questions. I'll answer those for you, just kind of checking in on that. So that's pretty much all the announcements I have to make. I want to make one more quick announcement unrelated to math. So the ASB director, Ms. D, asked, or rather reported back, that some students wanted short virtual workshops on specific things like working out, mental health. Okay, sorry, y'all. Yeah, it looks like my computer is freezing and situations are going on here. I think my recording is back up and running. Can you all hear me now? Hello, hello? You can hear me?
Yes. Hello.
Yeah.
Sweet. Okay. Yeah, I don't know what just happened. I was mid-conversation and it basically like refreshed my whole screen, and now I'm getting a situation that's saying my internet is unstable. So hopefully this gets remedied here soon.
Yes, that happens to me quite often.
Yeah, I hear you on that. But what happens when we have like, at least in my house, I'm living with a few people right now, so bandwidth is low. Okay, so I'm going to operate under the assumption that we are all good and we can hear me again. So if I don't, never hesitate. If you can't hear me, just be like, holler out and let me know you can't hear me. Okay. Um, all right. So what I was saying was, ASB director told me that some students, or not just told me, but told the teachers that some students wanted some virtual workshops on things unrelated to school. I think I'm going to do a quick little video on healthy eating habits. If you want to join in on that, I'm working on getting that done either today or tomorrow. So maybe you can
Dude, you
check that out
froze
and
again.
you'll see a familiar face there. I'm just going to give some recommendations as things that I've learned throughout my time and trying to eat healthy, and some example meals that I eat. Okay, so that's just obviously unmath related, but I wanted to give a shout out to that. If you were interested in seeing that, keep an eye out for that. I'm sure ASB will distribute that information soon. All right. Do I have any questions about anything setting up our material today? Oh my gosh. Thanks, Francis. It looks like when my computer freezes, it mutes me, and I didn't realize that. So sorry about this. Thank you for letting me know that I was muted. I'm just gonna have to work through this frustrating time of my computer freezing. I think it looks like that's gonna be happening. But does anyone have any questions before we jump into the material today? Sweet. If you do, unmute yourself or type it in the chat box. I'm gonna go under the assumption that we are all good, and let's get this party started. Yeah.
No, it's fine. I mean, we could.
All right, this is what we're doing today, everybody. We're continuing our journey through foiling the distributive property. We're going to start off on page 445, looking at problem number 12. So, page 445, problem number 12. This is again in module 4, looking at lesson 5. We learned on Tuesday that effectively one of the main ways that we work with binomial and trinomial, binomial 2x plus 4, and trinomial 3 terms, 4x squared plus 5x minus 3 multiplication, is using the extended form of the distributive property. So we left off on Tuesday basically looking forward at to 12a. So we talked about on Tuesday 2 different ways to do this, and one of the ways was the area model, which is part A, and then partner A, and then the other was partner B's work, which is going to be using the distributive property. I'm going to cruise through the distributive property a little bit quicker. I think it's more efficient in my opinion, but then we'll go back and we'll do partner A's work in a second. So effectively what I mean by that is the following. We're going to do this portion first, and then we'll use the area model to check it. Okay, so here we go. Again, this is on page 445, number 12. We're going to use the distributive property to find the simplified expression of this multiplication problem. Let's get it started. So distributing, making all the possible multiplication combinations. We're going to have 4x squared times 2x. And 4x squared times 2x is we multiply number times number, 4 times 2. And 4 times 2 is 8. And then we're going to multiply x's, x squared times x, which is just really a fancy way of saying x squared times x, or x times x is x to the third. Flash back to when we talked about exponential properties. We realized that when we multiply things that are like bases, we add the exponents. So 2 plus 1 gives us an exponent of 3. So now what we have, after just doing the first multiplication combination, and probably the hardest one realistically, is 8x to the third. That is the outcome or the product of the 4x squared and the 2x. Cruising. Here we go. On to the next. Let's use a different color. 4x squared times 4. So again, making all the possible multiplication combinations. Now we take that first 4x squared and we multiply it by the other thing in our binomial, 4. So what are we doing here? We're multiplying like terms. What's 4 times 4? 16. Does this x squared have anything to partner with over here? No. So it just comes along for the ride. Before I move forward any further, does anyone have any specific questions as to how I got the first two terms in this problem? Sweet. Let's get it going then. Orange. Here we go. I've done all of the 4x squareds. Look at this. This one's done. I made all the possible combinations with that 4x squared. So I move on to my next term. And my next term is 5x. So let's do 5x times 2x. Number times number. 5 times 2 is 10. What is x times x? Someone's saying I'm muted, but my screen is not saying that. So let me try to mute again. Oh, sorry, that's an old comment. 5x times 2x, 5 times 2 is 10, x times x is x squared. Sweet. Nice, Francis, you looks like you're pretty solid there, man, good job. So Francis has done most of the work if y'all want to check the group chat. But let's make our next combination, ready? 5x times 4. So we'll do 5x times positive 4. So once again, number times number, 5 times 4 is 20. Notice that x has nothing to combine with here. X has nothing to combine with, so it just comes along for the ride. It drops down to my work that I'm writing down here. All right, I am almost done with my multiplication, all the multiplication possibilities here. The last thing I need to do is multiply this -3 by everything opposite. So let's do that, ready? -3 times 2x. So we have, let me move this down just for sake of room. Cruising on down, we have this -3 times 2x. Let me zoom on out. And again, we are multiplying like terms, number times number. -3 times positive 2 is -6. X comes along for the ride. And the very last thing that we have to do now is the final part of our distribution. Distributing is just a fancy way of saying all the possible multiplication combinations. And we've almost done that. But the last thing that we have yet to do is -3 times 4. So -3 times positive 4, which gives us -12. Now, all of those multiplication combinations have been done. I'm seeing some of y'all writing that up there perfectly. Good job. All we have to do is see if we can combine like terms, because now we have this rainbow. And it kind of looks like rainbows based on our little distribution up here. Those almost look like rainbows, but we actually have, when I say rainbow, a rainbow of terms here in our final situation. And really what we need to do now is combine like terms. Thank you, Caitlin. Yeah, Delaney, page 445, problem 12. So let's combine those like terms. I have x squareds here. I have regular x's here. And then notice kind of our odd people out are the x to the third has nothing to combine with, and the regular number -12. So we continue to combine like terms here. 8x to the third just comes down because it had nothing to combine with. Let's do this in purple. What happens when we get 16x squared plus 10x squared? Well, we add the coefficients in the front. So we add the 16 and the 10. 16 and 10 give us 26. And since they are x squared, we have 46 x squareds. To work with green here for our next two like terms, we have 20x and -6x. So 20 minus 6 is 14. X comes along for the ride. And Francis has given us the final answer for this problem. Nothing to combine with, so it comes down. And what we have here is our final answer. 8x to the third plus 26x squared plus 14x minus 12. Now I want to ask a question. If you are looking at the chat, you see Francis's answer and my answer. They're super close to each other. I'm glitchy. I'm sorry, everyone. My connection is being weird right now. If you joined late, I was getting kicked out. So hopefully Hopefully my connection improves here. I have a lot of people, probably 4 other people on the internet right now, so I'm sorry about that. But if you look at Francis's answer, which he wrote as 26x squared plus 8x to the third plus 14x minus 12. What's the difference between his answer and my answer? Does anyone notice? It might be easier than writing in the chat box. But basically, what's the difference between option number 1 and option number 2? Yeah, the order. Great call, Mia. And while both Francis and I are 100% correct, I want us to get in the habit of doing the top one, the one that I wrote, because it's in descending order. And what I mean by that is we always start with the highest power and then we work downwards. And for those of you who have finished the ed puzzles already on key features of parabolas, order was super important on those ones. In those, on that ed puzzle, there was one problem that said, tell me what the A, the B, and the C are. And it came in this form. It said, all right, tell me what the A, I think it looked a little something like this, the B and the C. And the A is 1, because there's a 1 in front. The B is -7, and the C is 4. So I want to continue to get us in order of putting the highest exponent first, all the way down to the constant number or the y-intercept. But Francis, great work, man. You were totally right. So that's basically what's going here. I just didn't fill in the blanks there. All right. Does anyone want me to do the area model? I know I mentioned I was going to, but if we're really comfortable with the distributed property, I'm actually going to just cruise. If you want the area model, you can message me privately. You can change who you're messaging to from everyone to just me, Joshua Benham, and then you could tell me if you want me to do the area model, and I'll happily do so. So I'll wait about 10, 15 seconds, see if anyone wants the area model done. It'll get us the same answer. If not, we're just going to move on down to the next one right here. And while I'm waiting, I just want to say again, big shout out to y'all for being here. I appreciate how hard you're working. I know that this remote learning situation is difficult, so it means a lot to see y'all be here. Someone just messaged me privately. They like the distributive property better. Me too. I think it's more efficient. So cool. All right, so let's cruise on down to B then, okay? Again, at any time, if you want me to do the area model, let's get it done. But right now, it looks like we like the distributive property better. Let's go laterally or diagonally down to this one. And now we have a new problem. Here we go, distributive property. Boom. All possible multiplication combinations. What happens when we multiply x times x squared? Welcome new people. We're having a little bit of a glitchy situation today, but we are on page 445. New participants, page 445, looking at 12b. And right when y'all came in, we were looking to see if we could multiply x times x squared. Well, let's rewrite it like this. X is the same thing as x to the first. So what happens when we multiply like bases? We add the exponents. So x to the 1 plus 2 gives us x to the third. And no stress, Abe. You missed some good stuff, but guess what? There's plenty of time for you to get back on track. This is our distributive property conversation. And trying to make all the possible multiplication combinations. So you came in at a good time here on 12b. Again, page 145. All right, next multiplication problem. Ready? I notice I still haven't taken this x and multiplied it by everything opposite. So I still got to do that. So let's draw a little rainbow here from x to 6x. So I'm going to add x times the next multiplication combination, 6x. Well, notice we always do numbers times numbers, variables times variables. Technically speaking, this x right here has a number in front of it. It's a 1. So 1 times 6 is 6. What happens when we multiply x times x? We get an x to the second. Again, x to the first times x to the first. We add those exponents. 1 plus 1 gives us, boom. All right. Making progress. On to the next one. Here we go. All the possible multiplication combinations times -9. So plus x times -9. And now it's just going to be, all right, anytime the variable times a number, we just throw the number in front. We call it the coefficient. -9x. Okay. On to the next. Look at, y'all, we've done all of the x's. Everything opposite as we see in red, purple, and blue successively. So let's move on to our next term, which is -3. Notice it's a minus, a -3. So we're going to do -3. So plus, I'm trying to stay consistent with my addition, plus -3 times x squared. Again, anytime we just have a number, stack that number in front, -3x squared. Coefficient there, boom. All right, on to the next one. Here we go, -3 times 6x. Does any daring soul think they know the product to -3 times 6x? By the way, y'all, if you're joined later, if you're just now joining, we are on page 445, looking at problem 12b. And before I repeated that, I asked, does anyone know what the product of this orange problem is? -3 times 6x. Great call, Caitlin. Numbers times each other. -3 times 6 is -18. Since x had nothing to combine with, it comes along for the ride. Awesome. Are we done? No, but are we close? Yes, because we only have one more multiplication problem left, and that is that -3 one last time times -9. Negative times -4 makes a positive. What's -3 times -9? 27. Sweet. So we made all the possible multiplication combinations. We multiplied everything in the binomial, the 2-term situation, times every term in the trinomial, the 3-term situation. And then we have this rainbow-like algebraic expression. Notice not an equation, no equal sign, not solving for anything. Just now we got to try to combine like terms. So let's check it out. I have some x squareds. Sweet. A 6x squared and a -3x squared. I have some regular x's, a -9x and a -18x, and then a +7. And it looks like, Francis, you are super close there, man. Because now when we combine like terms, that x to the third has nothing to follow up with. So there it is. When we combine our x squareds, take a look at what we have here, y'all. We have a 6x squared and a -3x squared. So what does 6x squared and -3x squared give us? Well, positive 3x squared. And here's why. 6x squareds minus 3x squareds. We work with the numbers. 6 minus 3 is positive. Next up, we have, I'm going to highlight this in blue, -9x and -18x. So I'm just going to use commutative property to stack these next to each other. -9x minus 18x. What happens when we do -9 minus 18? Well, slash and dash tells us we could turn that into -9, and that gives us -27x. Done, 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 done. We just had one x to the third, so we moved it down. Does 27 over here on the far right have anything to combine with? No, it's the only number. It is just by itself. By the way, y'all, if this was an equation with a y equals, that would be our y-intercept. But it's not an equation, just a combination. So there is our final answer. Notice order highest power first, on down from power of 2, power of 1, and no power because it's just a regular number. Right on. I'm going to take a second here and pause. What are the questions? What do we got? Throw them my way. Cool.
Mr. Venom,
Yes.
for the distributive property at the bottom of the problem, do we still have to do that?
The distributed property at the bottom of the problem, are you referring to down here?
Yeah.
No, there's no distributive property going on down here. All
No, not that one, but like at the very bottom of the problem.
like right here.
Yeah.
Yeah, you could totally, but effectively, Delaney, we did all the distributive property right up here. Do you see my pointer?
Yeah.
So basically, the bottom is just like where they allow us to write our answer. I just didn't think there was enough room to do it all here, so I just did it in the blank space.
Oh, okay.
Effectively, and that's a great question. Effectively, if you wanted to write in the answer down here, you would just move each of these pieces on down. So long answer to your question is no, you don't need to. As long as you box your answer and show your work, that's totally fine. But they were just giving us these spaces down here to put those
Okay.
different information. It's just really hard for me to write that in that small space.
Yeah.
That's a great question, though. All right, so based on the fact that we don't have any actual questions about the process or the work of the distributed property, it looks like we're feeling pretty good. So that's good news. So let's see what our next concept was. Sweet. This is great, everyone, because we've already gotten to the lesson summary, which means we are done with the lesson, which means we have to answer number 14. Okay. So we made great time this week, y'all. This was all that I wanted to go over this week because I can't stress enough how important knowing how to distribute is. It will be super useful in this class in Algebra 2 Trig, and we're going to actually use this logic in reverse to help us solve. But we saw in distributive property, we just made all the possible multiplication combinations through distribution. And that's what the summary is now saying is, okay, we can just make all of these little combinations here. Let's do another one. Let's go black and use the distributive property and then combine like terms to get an answer. So based on the fact that one person actually let me know this individually, and based on the fact that nobody wanted to do the area model, I assume the answer to number 14 is which method do you like better? The distribution. At least that's my preference. I make a really bad smiley face. Cool. All right then. Has anyone began the homework here for lesson 5?
No.
No.
Caitlin, you have.
Nada.
Do you have any questions on the homework?
Are all the ed puzzles due tomorrow or just 3 of them?
Sorry, I heard a part of you, but it was really quiet. Can you repeat that?
Are all of the ed puzzles due tomorrow or just 3 of them?
Just a handful, just 3 of them. Yeah, I mean, you could do all of them if you want to, but those are the ones that are specifically due tomorrow are, I think, our key parts to parabolas and introduction to quadratics, those 2.
Okay.
Danielle, it looks like you started this homework as well. Do you have any, actually, let me just open up to the whole class. Does anyone have any specific questions on lesson 5 homework? If not, we're just going to we'll start at number 2. All right, if you have any questions, let me know. If not, boom, let's do number 2 here. Number 2 asks us to do an area model. Just following the directions, I'll do that, but I'm going to do a distributive property model in just 1 second too, okay? So here we go. Area model. We're using squares here, so I'm using a square or a rectangle. And I'm going to make 4 sections of it because we have 1, 2, 3, 4 terms. So we're going to FOIL here. So my first term is 10x. Where did I get that from, you might be asking? Oh, right here. And what is 10x being added to? It's being added to 1. So really, the way I got this 10x and 1 is if we think about it like a room, the length of this room would be 10x units plus 1 unit. And we got that information from the binomial right there. Can anyone take a guess as to what I'm going to put vertically? And Caitlin, you are correct. That is the answer, by the way. Great job. Yeah. And the reason for that is we know that when we are doing area of a square, we do the base times the height. So we just called, all right, the red is the base and the green is the height, so we can multiply them together. Now what we can see here is an actual application of this. We know opposite sides of a rectangle are the same. So if this side's x, that side's got to be x. If this side's 1, that side's got to be 1. if this top is 10x here, that's got to be 10x. And if this top here is 1, that's got to be 1. Okay, so now we just execute this whole process. Ready? X times 10x is 10x squared. 1 times x is x. 1 times 10x is 10x. And 1 times 1 is 1. Now we just add up all the pieces. 10x squared plus x plus 10x plus 1 gives us exactly what Caitlin wrote there on the screen, where our answer is going to be 10x squared plus x plus 10x plus 1, which when we combine like terms, thus x plus 10x is 11x plus 1. Now again, that is the area model way of doing it. I would do it a different way. I would use a distributive property, okay? And the distributive property is legitimately the same answers. Ready? 10 times 10 times x is 10x squared. 10 times 1 is 10x. 1 times x is x, and 1 times 1 is 1. We get the same thing, distribution or area model. Now we just combine like terms. All right, you do not have to do area model. Straight up, everyone. The area model logic is for those of you who don't like the distributive property, but since no one has said that they don't like it, distributive property is totally 100% usable. Okay, so let's transition and move to distributive property moving forward for all the rest of the problems. Cruising on down to number 3. I'll leave the answer. All right. Welcome in if you are doing some of the homework, so good time to join. Page 447, problem number 2 done. Problem number 3 is up, page 447. So here we go. First, we can do FOIL here because it's 4 terms. So we'll do 3x squared times 2x, 3x squared times 3. Sweet. Before we actually do those problems, I'm going to have someone jump in. I'm going to zoom in because it's hard to write that as far as zoomed out. Can someone tell me what the next multiplication problem in this problem is going to be? Anyone think they know? So we already did all the 3x squareds. 3x squared times 2x. Yeah, that looking good. I like the answers coming in. Good job. We are going to have an x cubed here for sure. We'll talk about what that x cubed is in 1 second. But my question was, what's the next multiplication thing I'm going to do? Fill in the parentheses, I guess, is more or less what I'm asking for. Anyone think they know? You can unmute yourself if you answer. If you don't want to answer, you can type it in the old chat box.
I'll wear one.
Uh, 2 times 2x.
All 2 times 2x, boom. So he realized that we'd already made all the combinations with 3x squared, so move on to the next one. And that takes us to our final multiplication, which I'll do here in blue, which will be 2 times 3. All right. So some of y'all wrote to me privately, and you got an x cubed for our first value, which is awesome. But keep in mind that we're multiplying the numbers in front, so 3 times 2 is 6. What happens when we get an x squared? X, we add the exponents. 2 and 1 give us an x to the third x cubed. So there's our first term. Let's do the multiplication of our green, because guess what? Before we do any of this addition stuff, we know first. So let's go. 3 times 3, ready? 3 times 3 is 9. And then x squared comes along for the ride because notice there was no other x. Francis, I see your answers. They're looking good. Right on. Super close there. And next up, ready? What's 2 times 2x? 2 times 2 is 4. X has nothing to combine with, so it comes along for the ride. And last but not least, 6. That's my favorite one. So now, do I have any terms here in this purple, green, orange, and blue? No. That's not a 6x. That's just a regular 6. So since we have no like term, boom, problem is done. You're good, man. I see you. That's a good fix, though. Okay, See if we get one more done here, okay? Anyone have a recommendation or request? Any problem? 5, okay, let's do it. Boom. Okay, cruising on down, next page, 448, problem number 5. 3x squared plus 4x plus 2. By the way, a little bit of academic language here, vocab word specifically. Boom, trinomial times binomial. I means 3, bi means 2, hence why we have 3 terms and 2 terms. All right, let's do 5 and then we'll finish off with 15, okay? So ready, 3x squared times 2x. Let's just do this like one step at a time. Ready? 3 times 2 is 6. X squared times x is we add those exponents. 2 plus 1 is 3. On to the next one. Here we go. Ready? 3x squared times the other term in the second parentheses, 3. 3 times 3 is 9. X squared had nothing to combine with. For the ride. All right. Cruising on. Here we go. We made all possible combinations with the first term, 3x squared. So this one, let me actually do this. You're done. We're done with your 3x squared. So here we go. Ready? 4x times 2x. Like terms times like terms, aka number times number. 4 times 2, 8. What happens when we multiply an x times an x? We get an x to the second. Okay. Now let's go 4 times 3. Anyone think they know what the outcome to the product of 4x times 3 is? AKA, what am I going to drop right there? 12x. Great call, Caitlin. 4 times 3 is 12. X has nothing to combine with, so it comes along for the ride. We are nearly done, but guess what? We haven't finished everything. We have to, I'm always looking at the first one. We have to make the possible combinations with this too. So 2 times 2x plus 2 times 2x. 2 times 2 is 4. X comes along for the ride. And last, but certainly not least, let's give Brown some love. I never use Brown. 2 times 3 plus 2 times 3. Oh, I love the bigger number multiplication. 6. Boom. Here we go. Combine those like terms. Do we have any? X squareds. Yeah, let's do it. 6x cubed. That's our biggest exponent. So decreasing order, highest power on down. It's going to be in front. Right on. Let's add up those x squareds. 9x squareds plus 8x squared. Keep in mind, since they're the same x squared, we can add up the numbers in front. 12x plus 4x. Again, since they are the same variable, x and x, no powers, we can add the coefficients. And the numbers in front. 12 plus 4 is 16. Does this 6 have anything to combine with? No. So it comes down for the ride. Is this written in descending order, highest power on down? Yep, 3, 2, power of 1. We are good. Number 5 is done. All right. I am going to keep it here on this screen for a little bit, for a few more seconds, because I know that that's a lot of information to try to copy down in real time. So if you need a few more seconds for page 448, number 5, there it is. And let's see if we have time to do 15 right now. You know what, Caitlin? I'm going to push off number 15 just due to time for today. I'm going to do number 15 tomorrow, okay? So if you can make it tomorrow during the Zoom session, we're going to do number 15. Maybe we'll get a couple more of these done as well tomorrow, like number 4, like number 11. But I'm going to push that one off. And if you can't make it tomorrow, please check in with the YouTube. So without any further ado, does anyone have any questions for me before we leave off here in a couple minutes?
No.
Mr. Adam,
Yeah, Delaney, what's up?
do you have like there's like the homework, not the homework log, but all like the answers for module 4?
Yeah, all of the answers are can be found as attachments in the specific homework assignments. So for example, let's go to our Google Classroom here real quick. So I'm on period 4 right now. So let's say we were in module 4. We're looking at lesson 5, the homework that we were just doing. So when you open it up, you should see something like this. The one at the bottom of the screen that says A1, M4, L5, TE. TE stands for Teacher Edition, and it gives you the answers right here.
Oh, okay. Thank you.
You're welcome. I do want to mention, actually, one of y'all that are in here right now found a mistake on number 1. And it's going to be kind of hard. Let's do this quick. Sorry, I was screenshotting that. So that's what that sound was. The mistake that one of you found was on number 1 on the, they did 2 times 2x, and the answer key was wrong. This should be a, okay. So just keep that in mind. Final is yet to be determined officially, but most likely it's going to be a project. We're going to have at least one project directly on quadratics, and then I'm going to probably do a project that's kind of on majority of the information that we've talked about this semester. A little bit of sequences, those patterns that we talked about, and addition patterns, geometric and arithmetic, and then a little bit of compound interest and quadratic, but that'll be in a project form rather than a pure test like the final last semester was. That's a good question. But more to come on that in the future. That we have about a month and a half until we cross that bridge, okay? All right, then on that note, y'all, I hope to see all of you tomorrow, where we're gonna be going over from 10 to 11 a.m. The Unit 7 assessment and some more of these homework problems, okay? So as always, I appreciate your time. I miss you all, and I hope you have a great day tomorrow, great day today. I'll see you tomorrow and or next Tuesday, okay?